Hello class, in this tutorial I'm going to show you what you need to do for problem 7.46. It's very similar to what we did in the previous chapter because we're going to be using these normal distribution probabilities to answer this. But the first thing you need to recognize for problem 7.46 is you're going to need to calculate the standard error of the mean or population standard deviation. They're basically the same thing. And it's very easy to do. We have our original standard deviation of 0.40 ounces. We were given a sample of 25 oranges, so according to the formula, we just take that 0.40 divided by the square root of n, which is 25, which gives us 5. So 0.40 divided by 5 gives us 0.08, and that is our population standard deviation that we will use throughout the rest of this problem. So this is just a matter of following some similar steps in pH stat. We will go to our probability and probability distributions to the normal. We have our mean of 4.7. Our standard deviation now is 0.08. And so these checkboxes should be very similar to what you performed last week. So the first one is asking for the second checkbox. The probability of the sample mean will be at least 4.6. So it's basically 4.6 or greater. So we just put in that value, click OK, and lo and behold, our probability is 0.89. For B, this is similar to just knowing about symmetric distributions. We have to take that value of 70%, subtract it from 100, which gives us 30%, and then split it in half, which gives us an initial tail end probability of 15%, and then 15 minus 100, you get 85%. So you need to run this twice using the cumulative probabilities. So we have our 4.7 mean, our standard deviation of 0.08, and then run this twice. Once for 15, and then again for 85. And so it's too bad we can't do it simultaneously. So I did it once here for 15%, got this x value, and then I did it again for 85, and you'll see you'll get this range value. So pretty easy. There's our range. And then for C, it's very similar in concept. You got to take that 77%, subtract from 100 to get 23%, and use that value as the cumulative percentage to get that x value, and that's 7.46.